Hey guys, what's up? My name is Akil, and in this video, our group is going to dive into something that sounds a bit sciencey, but don't worry, it's not as complicated as it sounds because we are talking about fractional distillation of crude oil. So, do you guys know what it is or no? Alright, it's okay. My friend Bud will explain to you what is this topic about. So I need you guys to sit back, relax, and get ready to become the next oil expert. Kind of. So, let's go!
Hi, my name is Bad, and now I want to explain about what is this topic about. What is crude oil? Crude oil is a mixture of many different hydrocarbons that is found in liquid form in natural underground reservoir. It remains liquid at atmospheric pressure after passing through surface separating facility. It is a complex mixture with a varying composition and also includes small amount of gaseous hydrocarbon, non-hydrocarbon and liquid hydrocarbon that derive from tar sand, oil sand, gasolite and oil shale. A specific crude oil can comprise a very large number of compounds that is not easily identifiable or quantifiable. Most of these compounds have a carbon number less than 16 and this forms a relatively high proportion of crude oil. What is fractional distillation? Fractional distillation is a method used to separate mixture, which is crude oil, into its individual components based on how their boiling point relate to each other. A low boiling point will separate first. How does fractional distillation work? A fractional distillation is completed with a setup containing a heating vessel, a fractional column, a thermometer, a condenser, a collecting vessel with the addition of heat.
Thank you for the explanation, Bud. So basically, do you guys know how does it works? No? Alright. So let me explain. Basically, crude oil is heated in a furnace until it becomes a vapor. The vapor then enters a fractionating column, which is hot at the bottom and cooler at the top. As the vapor rises, the heavier fractions, which is with high boiling points, will condense near the bottom, while the lighter fractions, which is with low boiling point, rise higher and condense near the top. So, do you guys understand? No? Alright, it's okay. My friend Alif will explain to you guys in more detail, okay? So, let's go!
Hi, my name is Alif Izzuddin, and now I want to tell more about how does this fractional distillation even work. So first of all, the liquid crude oil is heated within a chamber to about 350 to 400 degrees Celsius until most of it evaporates and forms a gas. Then, any liquid is drained off as the crude oil gas enters the fractionating column. Then, for the temperature gradient, the bottom of the fractionating column has the highest temperature and the top of the column has the lowest temperature. Next, the longest hydrocarbons will have higher boiling points. This is because there are more weak intermolecular forces between the molecules as they are larger. Therefore, more energy is needed to separate the molecules. The larger molecules will cool and condense and then turn into liquids at higher temperatures at the bottom of the column. For the shorter hydrocarbons, it will have lower boiling points. They have fewer weak intermolecular forces, so lesser energy is needed to separate the molecules. The shorter hydrocarbons will remain as gases until they reach the top of the column where it is cooler. They cool and then condense here.
Thank you, Alif. So now, I think you guys already know a bit about how does this fractional distillation work. And now, Azrul will explain to you guys about how the crude oil is separated and used. So what? So let's go!
Hi, my name is Azrul, and now I want to explain how crude oil is separated and used. So, how crude oil is separated and used? Basically, Throughout the process of fractionation distillation, the different boiling point of hydrocarbon are utilized. Depending on their boiling point, different fractions are formed at different levels of the column. At the beginning of the fraction distillation process, crude oil is heated and most of it evaporates. It enters fractionation column as a gas. As the gas rises up the column, the crude oil fraction cool and condense out at different levels depending on their boiling point. Each fraction has different property due to the length of the carbon chain. Therefore, we can use each fraction for different purposes. The shortest chain hydrocarbon are used for petroleum gas and petrol. Those with the longest chain can be used for heavy fuel oil and as bitumen for road making. Crude oil product. So basically, hydrocarbon can form new compound. Hydrocarbon from crude oil are used in the petrochemical industry as feedstock in order to make new compound. This new compound can form polymer, solvent, lubricant and detergent. Next, for carbon, it can form different compound. Due to its structure and bonding, carbon can form various compounds which have different properties. Compound with similar properties can form a homologous series. For example, alkene are a homologous series.
Alright, thank you Azrul. So basically we are already at the end of the video, but before that, let's summarize the different fractions from crude oil. Basically, the fractions are separated based on their boiling points and carbon chain lengths. As we can see here, the table shows the different uses of crude oil, such as cooking gas, chemicals, car fuel, jet fuel, trucks, buses, lubricants, ships, road surfacing, and others. These things are based on their carbon atom chains. So in short, as the boiling point and carbon chain increase, the fractions get heavier and their uses change from light fuels to heavy-duty industrial materials. So yeah, that's all from us. Thank you.